After we have some concept about the membership function, and then I'm going to present you the overview about the fuzzy inference system. That is the overall picture about the fuzzy inference system, that is from the input to the output. Now, when we talk about the fuzzy inference system, there are a lot of different names associated with this. Yes, fuzzy inference system, or in short, FIS. We also refer this to be the fuzzy rule-based system, fuzzy expert system, fuzzy logic system, fuzzy model, or fuzzy associative memory, and fuzzy logic controller, and just simply fuzzy system. They refer to the same thing, that is this particular structure. So when we talk about the fuzzy inference system, that is a kind of computing framework, that is the whole structure, that is using the fuzzy set theory and using the if-then rule to process the data from the input and generate the output. Yeah, so we can regard everything in this block. That is our brain. That is how our brain works to, as well as to process the input information and generate the result using inferencing or reasoning. Okay, so in general, when we talk about a fuzzy inference system, we have four components. That is the fuzzifier, the knowledge base, that is the if-then rule, and as well as the mechanism to do reasoning, that is the fuzzy inference engine, as well as the fuzzification, the fuzzifier. I will introduce each block one by one. Now, in the following, I'm going to explain these four units, and I would like to highlight that the domain of the fuzzy set, that is, we call this is the universe of the discourse. For example, in the driving application, the distance from 0 to 10, yeah, the distance from 0 to 10, we have this membership function, this range right here, that is the universe of this course. Okay, so take a look at this diagram. I summarize everything. How do I make use of this fuzzy inference system to generate the output using the input? Just to recall that our application is that I'm driving the blue car. I would like to keep the distance to be a safety distance. Yeah, so this is the distance right here, that is this region. So in the driving, if I'm the driver, I use my eyes to measure or to estimate the distance right here, and then based on this information as well as the knowledge or my experience described by this if-then rule, I'm going to process this information, and according to my experience, I'm going to generate some output at this point. That is some linguistic decision, and then I will talk about this later on. And with this linguistic information, I'm going to give the control signal to my limbs, hands and necks to control the speed of the car. So with my eyes, I just capture the information, say the input or the distance right here, that is 3.5 meter, approximately 3.5 meter, and then I'm going to enter that into this fuzzifier, because in my mind I will not process any numerical value. I'm going to translate that into something I'm familiar with, that is language. How small, medium, large this error distance, this distance it is. So associated with each fuzzy set or fuzzy term right here, I'm going to translate it into the membership grade in the y-axis right here. I call this is mu distance. Yeah, distance, that is the input right here. So when you substitute distance into the red, green, blue function, we will have the y-axis. So that is the translation. That means when I input 3.5 meter into the red, green, blue membership function associated with this term, I have the y value. Yeah, so this is what the fuzzifier is going to do. So for the web, I obtain 0.25. It just tells you that the first rule, it contributes to 0.25. And then now green 0.83, and then second rule contribute to 83%, for example. The red one, the blue one corresponding to large, it contributes 0 because the Y value right here, that is 0. What I'm talking about, that is this membership grade. So up to this point, I come up with this information according to the rule base. Yeah, so the rule base, that is combining with the experience, combining with this fuzzy, combining with this crisp value and membership function, I would say that it is 0.25 of small. So according to the then part, the speed is not very low because the contribution of this rule is not much. 0.83 of medium, and then this rule contribute more, and then so I would say that it would be more steady. Yeah, and then the next one, 0 of large because of this value. So according to the then part, it just tells you that definitely the speed is not high. Yeah, so combining with the knowledge, experience, as well as the membership grade, that is the fuzzy input to this fuzzy inference engine, I come up with this table. So fit in this table into the fuzzy inference engine, I will come up with the output that is given by this text box. The speed should not be very low because of this rule, and more towards steady because of 0.83 of the rule 2, and but definitely not high because of the third rule. So I come up with something like this. That is the point right here. I obtain this information, but this decision cannot be understood by the actuator, that is my hands and necks. So I have to translate this sentence into something that my limbs can understand. For example, if I'm talking about a robot, maybe I'm going to translate this information into the voltage level of a motor. Yeah, so I'm going to translate this information into the output crisp value, that is a numerical value, for example 20 miles per hour. So this is the overall picture. Each block has its own purpose to do. Yeah, and now I'm going to talk about the fuzzy fire. Yeah,